Hi, my name is Scott Southworth. I'm a consulting integration engineer at HCA Healthcare. If you haven't heard of us before, it's a Fortune 100 gigantic megacorp. We have, counting contractors, almost 500,000 employees, so I'm kind of in the Walmart neighborhood of things. And we have been looking into Elixir and doing experiments, and I'm going to give you a bit of kind of a backstory about what programming in healthcare is like, because I know that a lot of people here are at traditional tech companies, and I've worked at some of those, but the healthcare industry it's gone through a long history of not wanting technology as something they do. It's something they buy. And we're trying to change that right now because, as most of you know, there's some amazing powers you can unlock when you've actually got developers working for you. And so we've got kind of a three-phase program. What got us here, kind of going historically through like the last 50 or 60 years, pretty briefly. To create the situation we find ourselves in, how we are currently trying to fix the situation, and then lastly, kind of future plans and what we're looking into. So I want you to understand that, when you go to a hospital, there are tons of messages traveling back and forth between different systems. Your lab results, your pharmacy orders, the fact that you've been admitted or discharged, or just vitals that are flowing from place to place. Even messages that are healthcare messages that go into the supply chain and restock your toilet paper. But we have this huge amount of technology that's backing it, and when it screws up, people die or suffer really terribly. And it's not managed nearly as well as a lot of more traditional companies would have their tech. It's very new for us, and not a lot of people have been doing it very long or well. And mostly, I think places like HCA are not usually developers' first choice of jobs. You're not out there thinking, I would really like to join a gigantic faceless megacorp and work on, a really messy, disgusting hospital record that barely anyone can comprehend. And the thing is, if no one does, it's not going to get better. And so I'm asking people to think about it, to look into these kind of jobs, look into this market. So the systems that contain your healthcare information are called EHRs, electronic health records. And we go back in time to 1966, and someone decides they're going to create a programming language specifically for the healthcare industry. And that language, the Massachusetts General Hospital Utility Multi-Programming System, or MUMPS, they actually name their programming language after a disease. And it goes into the wild and becomes the foundation for the majority of the systems out there. Now, MUMPS had some advantages. This is the very early days of computers. We've got really cool features. A lot of you have had to deal with the fact that usually you multiply before you add, or just different aspects of operator precedence. We don't have to worry about it anymore. Left associative, just reading a line. The database is built in, so like your variables can be used as set to just persist to disk, uses some kind of like sparse B tree under the hood. It's got proprietary file systems that people have kind of added onto it, and then those companies kind of lock everything down, and you'll see that causes us some problems later on. So in 1972, we get our very first DHR. And from that point on, more and more of them spread, but this isn't like taking off like wildfire. But note, all of these are being set up, configured, and designed without any thought to the internet, because it's not really going to be in wide circulation for quite a few years. By 1987, we have this new standard, which is exciting, called HL7. It's from the OSI model, level 7, the application layer of networking. And basically, version 2 of HL7 becomes the most widespread communication standard in healthcare. The problem is that almost every single company, like your vendors, your hospitals, your clinics, your labs, all of them make unique implementations. And so when you have any two systems talking to each other, you have to integrate them where you say, I would like to format the message as such and change like how wide it is, the way it's organized, or you break the end system because they're hyper fragile. HL7 has some really interesting features. Custom delimiters for every message. That way, you parse it just enough to figure out how you need to parse it. Also, unlike HTML, XML, or any of JSON, modern YAML structures, it's got a hierarchy. You have orders that have observations, and then nested within those can be like optional notes, and those can repeat, and patient visits, and are just all these structures. The thing is, the message comes across as flat, like an array. And you just have to know what the hierarchy is implicitly. And that hierarchy could vary from vendor to vendor. So these are all really exciting features. I know a lot of you are already thinking that you might want to change careers. So in 1996, there's this big law, a lot of you have heard about HIPAA. It actually kind of revolutionizes this industry because it provides guidance to securing your data, and it forces a lot of companies to hire software developers. And the thing is, a lot of those software developers don't actually work for the companies because they subcontract it out and start gluing together purchase systems. It does produce a lot of jobs. A lot of people get employed. You also see that it becomes harder to defraud Medicare, which is pretty awesome. My company found that out. We used to have a CEO named Rick Scott. He oversaw the largest Medicare fraud in history. It was really enormous. And after kind of finding a way to take a lot of money from old people, he then moved to Florida and became governor, where he could now continue his operations. But thankfully, our company was saved from that, and it's kind of rebuilt itself. Like, it's kind of viewed as our dark legacy. In 2009, we come out with, I guess concurrent with Obamacare, the Affordable Care Act, the High-Tech Act. And this one adds something called meaningful use. And meaningful use is basically saying we want all of these hospitals to move to having electronic records, but we don't just want to say you should just have electronic stuff. we want to actually make sure they're doing something with it, that we're actually getting some kind of value out of the mess we've got. And so this actually turned out to be a really important thing and has driven a huge amount of work that's happened. So just before this passes, you've got 2008, 9% of your hospitals are using electronic health records. And the systems they're using to do that most commonly are called Cerner, Meditech, Epic. Those represent the majority of the market share. So imagine this. I mean, that's roughly 10 years ago, practically any hospital you went to was running on paper. I mean, this is like the iPhone's coming out, your hospital's on paper. Everything's being written down. By 2019, this number jumps to 96%. So there's not a large history here of hospitals having this kind of access to data. And it's kind of creating this wild west of we've suddenly got all of this health information and we can do so much stuff, but we don't have the talent or the infrastructure to do it. So this has kind of begun our fight to get the data. Those EHR systems, generally proprietary. There's an open source one called MUMPS. I think it's written in PHP, but it doesn't have a lot of market share yet, at least in the US. And a lot of the companies that made the EHRs do not want the data to get out. There's a lot of money made by holding it in. And so we have basically a situation where we will actually go to our EHR vendor and say, we'd like to get data out that we of our own customers, and we have to poke a straw in it, and we pay for every straw we stick in it. So those companies would then have employees leave, and when they left, they would start companies that knew how to poke straws in the proprietary file formats, and they would start licensing it out to us. So with the internet and consolidation in the industry, more and more stuff starts getting tied together. And we can connect hospitals. They'll have data that they can give us. It won't have time zone information or UTC because it was stood up before the internet existed, and it kind of bites. But it starts coming together. You have these integration engines that tie messages between all of these different systems that hospitals need together. So, hospitals, clinics, pharmacies, insurance. Insurance is huge. An enormous amount of time is wasted trying to just do billing. Suppliers, your imaging centers, your laboratories, your banks, a lot of stuff going to our corporate systems. The HL7 messages that form most of this are being transmitted in a protocol called MLLP, the minimal layer protocol, something. It's basically just wrapping HL7 messages in a couple characters and sliding them down a TCP socket. So what we've got right now is thousands of vendors, hundreds of facilities, and over 80,000 manually configured point-to-point socket connections, sometimes with custom logic to bridge the differences between all of these different systems. Millions of messages flowing every day, and if they don't get through, something catastrophic can happen to someone. And as it says at the bottom, they're being modified on the fly on a case-by-case basis quite often. And we're already kind of struggling with that. And now we've got the advent of IoT data, and we're looking at this situation where we could have 100 times as many messages coming through. Every single bed in every single hospital has ventilators and IVs and blood pressure monitors. And we can have all of these devices now sending us live feeds from every single patient. Then we can correlate them with all the other data from their visit, and we could give immediate feedback to what's going on. But we don't have the system to do it. So we're trying to figure out what can we do. We know we can't do what we're doing now because what we've got now is even with the messages we do have, a lot of them are going through, if you've heard of ETL batch processes and whatnot, these things are being loaded into enormous enterprise databases and warehouses, and the next day you can run a SQL query on it, and you can be like, we should save this patient who already died. So we know we can't continue there. So we've tried our best to make things happen. We set one kind of alerting system up very manually, which required a lot of work, setting up those little point-to-point connections. And that was called Spot. And this has had a lot of media coverage. It was the Sepsis Prediction and Optimization of Therapy. It basically, if you're not familiar with sepsis, it's kind of a blood poisoning. It's got a 30% mortality rate if you're in a hospital. And we have many thousands of patients every year who die from this. And it's somewhat avoidable if you can catch it early, if you get the signs and symptoms. And so what this system would do is it would send as much real-time data as we could get, and we had what they would call artificial intelligence machine learning, but mostly complex event triggers. They would go out and alert doctors, we think this patient is going septic. And it's been remarkably successful. Over the last 3 years, 5,000 people have been saved because of this, who otherwise would have died, at least statistically. Our mortality rate has dropped significantly in our hospitals. And HCA is working right now to take the algorithms we've developed for this and to try to spread those to other hospitals in the nation so that it can be applied elsewhere. So if manual configuration isn't going to be an option for us going forward, we're looking for some way that we can create a really scalable, automated system that we can start leveraging. So for that, there's been this huge sea change where rather than doing what we did before, which was we'd go find a vendor, we'd buy a product, we'd buy another product, we'd hire really expensive consultants, and they would try to just make the two work together. There's been this realization that maybe what we should do is actually hire people to build exactly what we need. And so now we are doing that, and we've got different teams who are working in Elixir and Clojure and Python and just a variety of different technologies. We've got a data science department, and all of these people are experimenting and trying to work out what can we do with our existing infrastructure and our data to try and make things better. So on our team, which is in the integration sphere, kind of the heart of where all the messages are currently flowing, we have been looking at Elixir because it has had enormous success with huge messaging throughput from WhatsApp, or at least the Beam, and Discord. And it's gotten just, I guess, my team incredibly excited about the possibilities. But to be able to do anything, we have kind of these medical standards, and because it's kind of a niche, and Elixir is already kind of a niche community, libraries didn't exist to handle things like HL7 or MLP or the upcoming standard, which is called FHIR. And so we spent quite a bit of time working to develop some of these foundational things. And so we finally, for a non-tech company, got our first lawyer-approved Elixir library on Hex, which is Elixir HL7. And you can check that out. I was going to show some of how that works. We've got an MLP library that's out on GitHub, though we're still working on aspects of it. And we're working on a FHIR library for people who are interested in a much more modern approach to messaging that seems to be what's going to be the staple going forward. So this isn't my first library I've written, but it's the first one that has extensive documentation. And if you're new to Elixir and you haven't used Xstock, it is amazing. You're basically writing code and comments, together, and like you can set up examples for how you want things to work. And so your documentation has examples that are then tested and run with your documentation, and all of it's packaged and put in a beautiful format on hex. And I mean, it makes it easy enough that I was willing to do it. And it's one of the things that frustrates me about some of the Elixir libraries out there is, it's really tedious to write documentation, but it's really hard to get into something if there aren't examples. And just little snippets just showing you how things should be used are really helpful. So the library is basically designed to let us parse, validate, route, just reading header information and sending stuff off, or do queries and modifications on these messages. Our first attempt, we went out and we found XSDs, which are XML spec documents, really fun to read. And we generated modules corresponding to every data type and every message type, which turned out to be several thousand. And then we tried running Xstock, and it basically ate up 30 gigs of RAM that started paging to disk, and it took almost an hour, 40 minutes for my computer to generate the documentation. And I ended up talking to the Elixir team about it, and we tried making some hacks to Xstock to see if we could improve that. And finally, they came back with, "Don't do that. Why are you doing this?" And so we then had to switch gears, especially because when we actually started running our production data through our library, and we had millions and millions of messages, which made it really nice to be able to test and see what's going to work, we find that no one follows the specification very strictly. And so actually using the real spec is detrimental to accessing and working with the data. So now we can just parse it to nested lists and strings, and then that's okay to work with, but it's not great, until I finally had this realization that each of these HL7 messages is no different than like a document, a structured document like XML. It just, we can treat it as such. And so I don't know if anyone's used D3 or jQuery. jQuery at least used to power a vast amount of the web. And D3 is a data visualization front-end tool that is amazing for binding data with elements and kind of setting up transitions. But we used, I kind of went with what I'd used on those in the past, and I stole as many of the features as I could out of them. So CSS selectors, which kind of correspond to segments in our HL7. jQuery will basically let you go into a DOM structure and grab back arrays of elements that you can manipulate. And then you can also bind data to these and do sub-selections similar to D3. And I think the most important thing, which I only realized a little late in coming to functional programming, is that there are a lot of functions in functional programming which are beautiful because they take a really small input and they do something really small and they return, and it's very composable. But one of the things you can do when you've got something like this giant document is you can maintain kind of an opaque data structure where you can hold the selections and manipulations you're making with the original or with the document that's kind of not being affected, so that you can take all of it and reconstruct or manipulate the whole thing en masse. So I'm going to show you the library. This is really, really ugly in terms of HL7, and I've got garish oversaturated slides, so that I guess won't be too much of a change. Here is, in the library, we've embedded examples so that since most people aren't going to have HL7 documents lying around, this is what it looks like. That's from the NIST. You can see it has a 3-letter beginning to every line. That's called a segment name. From the top, it's like MSH, which is the header, PID, patient identifier, stuff like that. And there's actually a hierarchy to that, but it's flat in its current incarnation. So you can just dump these out in your REPL. It's the Wikipedia sample. You'll see here, to parse into it, like right after the message header, the little highlighted in red area, those are the delimiters that the person is going to use in the message. And so most people use the same ones, but you can change them, unfortunately. And they use carriage returns instead of new lines. So if you want to dump it out, you have to do a quick replace. This is just showing like highlighting steps. You can see there's the message header. Message type is ADT. That stands for admission discharge transfer. Here's a patient identifier segment. So that's basically who you are, and that's how you're moving around when you're at a hospital. It's got like your account numbers, name, address. Here, this is like the clinical information that came back on this message. OBX segments, which are observations. Got an allergy to aspirin, diagnosis, unspecified chest pain. So we take this, and we can use a toList function on it and you'll see it kind of creates a simplified structure you could work with, but that's not a lot of fun, and it's very, very, very long. It'll keep going for pages. So when you do create like a new message in it, also extract all of the header information for you. So you're going to see like what the version is, date, times, etc., what facility it was from. But if we really want to manipulate it, we needed something a little more advanced, and that's why I set up an HL7 query module. And you can check this out on Hex with actual docs. Here's what it looks like. I'm a huge fan of, I guess, trying to make very simple Fluent APIs. And I love the Elixir pipeline operator. You can see here, what this would do is, if I had a message and I wanted to get all of the diagnoses associated with patient visits only. This is kind of a contrived example. What I could do is that selection there, and this is where Ben Church's last presentation, where he was discussing having a Elixir parser, that would have been awesome, because I just wrote something by hand that's probably not as good. But this little notation you see with PV1 and then the brackets is basically something where you can say, I would like to select a patient visit segment, and then it can have optionally and repeating, possibly, diagnosis segments. So it could be 0 to many. And it would select those as groups. And then I could perform a subselect and say, well, any diagnosis with a patient visit, I'll select those. And then I could grab parts out of them. That's the third field, second component. I can just pull information out. The way it works is it basically, it's similar to D3 if you've used that, which I'm going to guess most people haven't. But you basically get groups that are selected en masse. And So that first selection gives you one group of the 4 segments. And then when we subselect into it, we end up with 3 groups of 1 segment each. And then we can perform our get parts to grab back a flattened list of data. And so it's also got a number of different manipulation type functions. So like here, if we wanted to just delete all of the diagnoses that are only associated with patient visits, after we select it, we could just pipe it to a delete and then reconstruct it to string or to message, and it'll actually just mutate the whole thing right there and reconstruct it. Here's an example. You can do kind of lambda replacements if you want. Going in and that's saying find all the OBX segments, the third field over, kind of, it gets sliced into, it has like 4 levels of nesting. So that's 3.2. That's the way people like in the industry will refer to things as like OBX 3.2. And so the syntax is actually designed to mirror the way the business currently uses and refers to these things. And then here, if you need to make multiple changes on a document, what you would do is like here, it's basically eliminating certain segment types and then goes back and kind of reselects everything from the beginning. Then you can perform more operations, or in this instance, just show what's there. And if you want to see what's happening under the hood, like here's an example of making a selection, and that that notation with the brackets and the curly braces, it can be nested. So you can have, in some of these you'll have like a group with an optional repeating group. You can have optional repeating groups inside it. So it can be relatively complex to do this. So you can dump this stuff to the console. When you do that, it has a color-coded output where it'll show you the different selections you've made, and it'll number them within each selection. So where can we go from here, and what are we working on? So one of the big things is called FIRE, and we're trying to build a library on that right now. It is kind of, instead of having a specific format, it's defined as a set of structures and actually has multiple outputs, XML, JSON, the famous turtle, if any of you have used that, turtle? No. And it has some issues, but it's a lot better than HL7. You can't use its JSON in a browser or with Elixir's JSON because they're defining a standard and they decided not to necessarily go with the JSON standard in particular, which I complained about on their forum, and I was told I was, quote, not going to make friends in the FIRE community, which my coworkers still chastise me for. I was a little, I led by saying, why would you break the JSON standard? And yeah, didn't realize the person who was responding to me was the actual creator of FIRE, which is foot and mouth for my employment. So here's another thing we're looking at is the actor model. And so we're looking at setting up our integration layer where we could theoretically have, for like the 1 million patients we might have in recent memory for HCA at a given time, have each patient represented by an actual actor process. And they can like accumulate their events and projections from them and emit alerts in soft real time. And we would be able to let people query like what's up with a patient from anywhere, like in our corporate setup. We could tie things into public health and outbreaks. All of these things are completely impossible right now. So one of the really cool things we were looking at recently is called ventilator alerts. So if we do have all of these devices at all of the beds, and we're looking at getting ventilators that will be sending information back about how someone is breathing, we need to basically watch all of that data in real time and respond to it. Right now, when you're on a ventilator, you can have what's called a spontaneous breathing event. And that means you start breathing on your own instead of needing the ventilator. If a nurse is right there and they're like, oh, they just started breathing, we can take them off the ventilator. You are good to go. If they miss the spontaneous breathing event, you might die. Like, it's one of those things where if they don't catch it, your window of opportunity will pass. So this is something we would love to start rolling out. Another one that we're looking into is stroke alerts, and we actually have a kind of a beta of this running right now on a different system. But if you have a stroke, there's a drug they can give you, and it's hyper effective at reducing the symptoms that you would have, where, like, being crippled possibly for the rest of your life. But they have to give you this drug within 60 minutes of you reaching the door generally. That's kind of the window. And most people don't get that. And so we're trying to set systems in place to make sure that we can tie all of that together. Another thing, much like Ben's presentation that he just did, with all of the customization that's required from system to system, that we're not going to be getting away from anytime soon, because it depends on so many other thousands of companies. Right now, having programmers implement that is an enormous overhead. And a lot of it is very business-specific language. And so I would like to move more of that onto what would be a business analyst role, where people are paid to do like minimal programming, but I don't want them to be able to create that fire in the code base. And so we're looking at kind of a WYSIWYG system where here's an HL7 message on one side, here's another HL7 message on the other side, and you write basically Lua code, and that's using the HL7 library, and it can show you how the message would be transformed in real time. And since it's Lua and not Elixir, you can very safely sandbox it and prevent them from doing things like, using your file system or your network or causing rampant CPU usage. And there's an Erlang library for that. It was built by Robert Verding, co-creator of this ecosystem. And got a Elixir wrapper that we put out on Hex called Sandbox, if you're interested in checking it out. And that is my talk. Thank you very much. I apologize for the ugly slides and lack of GIFs, but I was wanting to try and just keep it straight this time. So you can find me on Twitter, at GitHub, Hex, and whatnot as Dark Marmot.
Thanks, Scott.
Thank you.
Do we have any questions for Scott?
I was just curious how the creator answered your question on the forum. Why did he break the JSON spec? Or why did they break the JSON spec?
Oh, okay. So here's what happened. They eventually invited me to go to their off public forum, but the private developer forum. And I was a jerk because I was upset about this because I'm trying to write a library at some late 1 a.m. in the night, and I was not. I was rude. But they eventually, we discussed how the problem was in JSON, you cannot normally encode precision, and in hospitals and scientific uses, there's a big difference between 2.00 and 2, because you've got so many significant digits you're dealing with. And they could have encoded it either as a string or, here's a 2 and you have precision to the 100th place. But they didn't. What they require is that you input and output it with all of the decimals, but almost like in place, and don't drop precision on a float. But almost no parsers out there actually behave like that. And the one that I would consider kind of the go-to standard would be the browsers, because you're sending this over the wire and people are receiving it in web pages, so you'd at least want to conform to that. And they told me that that when I got on the developer forum, lots of developers started whining about it. It's just no one had brought it up. And some of them were saying, well, we just don't care, and we're not going to bother. And others are started saying that, yes, we also forked the JSON parser, and I forked JSON to hack this in. But and they got really mad because the creator did, because he'd waited, he said, 6 years before they decided this is normative standard, and we're locking it down. And then to have that brought up, they were just pretty irritated.
So do they call it JSON?
Do they call it JSON? You mean JSON versus JSON?
No, Fire, you said it can output XML, JSON, and Turtle. Do they actually call it JSON if it's not actually JSON?
Yeah, and it has a big, and this is the thing, can you not be aware of it? Because on the Fire documentation, they have a giant dragon breathing fire with a warning that says, you can't use JSON.parse or other libraries. So it's not like they weren't aware.
Yeah.
I found it to be pretty hypocritical when you're making a standard.
They should probably name it something else then.
But I don't have friends there anymore.
Anybody else have any questions? Okay. And I can also relate to making somebody mad who created a thing and not knowing they created it until I made them mad. So I understand.
Hi, so you mentioned that the healthcare is kind of pivoting towards hiring internal development and trying to push their own agenda as opposed to being purely vendor-driven, as it's been historically. Do you feel that you guys are still in an antagonistic relationship with the data holders like Epic and things like that?
Yes. And
so, I guess I just like to hear you expand more, because my company has considered trying to break into healthcare through a lot of contacts we have, and I'm curious to see what the hurdle is to get in, especially if HCA and a lot of the other big hospital corporations are maybe kind of starting to close their perspective on working with external vendors. So I'm just kind of curious how that's.
I mean, we're still working with tons of external vendors, but yeah, it's getting easier to get our data out. The newer versions of the EHRs are adding additional features and are opening up somewhat. And I talked to one attendee here today who was telling me that there's a new rule in place that might force them to open things up, which would be amazing. So there is a light at the end of that tunnel.
Cool. I think that's all the time. Wait, huh?
Oh.
Where are we at? Wait, who has a question? We have time for one more question. Oh, okay. Thanks, Scott.
Okay, thank you.